So part one of your test is tomorrow. Like I mentioned yesterday, the circuit training is a really good test review for tomorrow's part of the test. It's not due until Monday, but if you did it for tomorrow's test, that would be most beneficial to you, okay? Because it's very similar to the questions that you'll notice on here. Then you're going to see as well, tomorrow's part of the test is going to be pretty much all of our calculation type questions, okay? Just, what's the sine of this or the cosine of this or simplify this identity, that sort of thing. No proofs at all on tomorrow's portion. And tomorrow you will be allowed to use your graphing calculator because the first question will be a graphing question. And then you can use your graphing calculator, of course, to just check if the answers you're key to. So we'll do that tomorrow. And then Friday, all we're going to do are just practice proofs as you guys need to. There's not really any traditional review. We can put some on the board and you can try and just go through them, or I can do a review if you want, like spot check them. But Monday's portion of the test is going to be 6 proofs, and you have to prove 4 up to 6 is your goal for Monday, okay? And that's it. So calculations tomorrow, 4 of 6 proofs on Monday, and that makes up the 2 parts of your test. Remember, you will get a blank unit circle and this formula sheet for both parts of that test. Yes. Is there a bonus on the truth? Good question. So originally no, but then we talked and decided that those sum to product to sum identities, instead of counting them, we counted them as bonus a half point each. So instead of it being out of 38, we made it out of 30. And then those last 8, you could earn half a point. So several people got over 100% because of that. It was so nice, right? We were in a good mood yesterday. So, okay. So first question, we are going to need to disprove an identity both ways. Algebraically, which is where we prove by disprove by a counter example, plugging a number in, showing it doesn't work. And then graphically, showing that we get 2 different graphs when we graph both sides of this equation. All right, so pick a number. What do we like? 55. Looks good. Okay, so let's do the graphing part first, if you guys want to get your graphing calculator out. All right, number 1. I would make sure that my calculator was in radian mode to start. Unless you're typing a degree in specifically to check an answer, everything should be in radian mode. Okay, so radian mode. And then we're going to go to y equals and just clear out whatever you've got in there. Okay, and our job now is to type the left side in y1 and the right side in y2. And then we're just going to compare the 2 graphs. All right, so I'm going to use my alpha y equals, and actually let me see if it works on here. It does. So I found a little shortcut yesterday. I was very excited about it. Instead of hitting alpha y equals, you can hit alpha and then the X button right next to it, and it brings up the fraction. Isn't that cool? Okay, I didn't know that was a thing. Okay, so I need to type in tangent squared. When you type in tangent squared, I need you to make a parentheses, tangent x, and then end. It creates 2 parentheses, so end both of those parentheses, and then square, okay? So it looks a little different than what we see as it's written. It's the tangent x, all in parentheses closed, squared is how we type in anything squared. And then minus 1. On the bottom, just tangent x, end my parentheses, plus 1, okay? Then go down to my y2. Again, set up a fraction. 1 minus, how do we type one of these reciprocal functions in? How do I type in cotangent? Cotangent is the same as what? 1 over tangent. So that's what we're going to type in. So I'm just going to set up another little fraction. It's going to put a fraction inside of my fraction. 1 over tangent. Okay, and then the same thing on the bottom. 1 plus, set up another fraction. 1 over tangent x, end my parentheses, and now I'll kind of drag that over so we can have it as part of our solutions there. Okay, that's how we're typing it in, sort of. Kind of see that top one got cut off a little bit. Okay, once you've got it all in there, we're just going to hit graph, just so your standard window should work. The color one's really nice because it tells you which one's which. If not, just kind of pay attention to what's graphing first and what's graphing second, but it should look something like this. Does everybody have something like that picture on their screen? Okay, and remember the idea is we're disproving here is the goal, so we should see two different graphs. If you don't see two different graphs, you did something wrong. And then you're just going to take that picture and you're going to sketch, and then if you had to explain why that means it's not an identity, what would you say?
Now, like, both completely the same.
Yeah, the graphs are not the same, therefore it is not an identity. Okay, very plain and simple once we have this picture. Okay, so that is disproving it graphically. Okay, then you will also have to disprove it algebraically. And let me see here. I'm just going to add another page. Okay, so we had tangent squared, was it minus 1? Minus 1 over tangent plus 1 equals, and then 1 minus cotangent over 1 plus cotangent. There we go. I think I wrote that down right. Yes, it did. Okay. All right. And now we want to disprove it algebraically. Now you can use, this is why I did the graphing one first, you can kind of use the graphing calculator to help you. I, for example, would probably not want to pick 0, because if you look on the graph at 0, or x is 0, you can see the graphs are actually going to be the same there. So if I plugged in 0, I would get the same thing on both sides, and then we would have an issue, or at least it looks like that. So we could pick something else. I mean, it doesn't really matter what you pick, as long as you get two different things and you have your graphing calculator if you need it. Maybe like 90. Want to try 90? That's tangents and cotangents are kind of pretty there. Okay. And if it works, just pick another one. So let's let x equal 90, and you can use degrees or radians. I would definitely highly recommend using something off of your unit circle, because then you can get nice, pretty exact answers with this. Okay,
Like, say you just, like, pick 90 and it happens to be, like, could it happen to be, like, that they are the same? Well, I guess you would see. But...
You would see, yes. One thing that you could do with the graphing calculator, let me show you here. So you could, it's going to be easier with degrees, change it to degree mode. And then go to your table, and you can scroll in the table. These are all degrees. Actually, if you look at 0, it looks like 0 is not going to work either, because there's actually an undefined value. There's like a hole in the graph that we don't see in that picture. But anywhere where both sides are different is a degree that you could plug in, and this is what you should get if you plug it in the left, and this is what you should get if you plug it in the right. So, I mean, if you wanted, like, I don't know, something else from our unit circle, like let's say 30, you'd have to scroll down a little bit. But then you can see 30, I know isn't going to work either, because I get two different things on either side there. So that could maybe save you some time. But yeah, let's say you just plug it in, you don't mess with this, you get the same thing on both sides, just pick a different number. Okay, yep.
Couldn't you take like 2 and then just put it in the calculator?
I would prefer you to have exact answers,
Okay.
please. So pick something off of your unit circle, but you can use this to check your answers. Okay. All right. I'm going to use 90. Well, actually, let's just use 0. 0 kind of looks like we know what we should get, right? One side's going to be, what, 0, and the other one's undefined, or 1 and undefined, something like that. Okay, so tangent squared of 0 degrees, or 0 radians, doesn't matter, minus 1, over tangent of 0 plus 1 equals 1 minus cotangent of 0, 1 plus cotangent of 0. Okay, tangent of 0 from your unit circle. So think about, we go 1 unit to the right, which is the coordinate 1, 0. The y over the x, the y would be 0, the x would be 1, so we get 0. 0 minus 1, because 0 squared is still just 0, right? And 0 plus 1, so that whole side simplifies to -1. And if you wanted to check, you could check that value in the calculator, okay? If I do cotangent of 0 off of my unit circle, it ends up being the reciprocal of that. 1 over 0, which what happens when I divide by 0? It is undefined. Okay, so what I have is 1 minus an undefined value over 1 plus an undefined value, which we cannot simplify that. It is undefined. So they are not equal, which is what we are trying to show. Okay, so lots of different ways that you can show that, but please pick something off of the unit circle. Please use exact values. If you end up with decimals, you can look at the table and make sure your decimal matches what it should match. Okay? Any questions there? All right, so counterexample is algebraically. Don't try to prove it. It's not provable. If you try to use identities, it's not going to work. Okay. All right, so the rest of the problems then are just using the formulas on your identity sheet to simplify and find exact values of things. Whatever answers you get, you could check in the calculator if you have extra time. Okay, pick a number. 11, sine of negative 105. Perfect. Okay, so if this wasn't a degree, I'd probably turn it into a degree first. What do you multiply by to turn something into a degree? 180 over pi. Okay, so we don't have to do that on this one. The other thing that is optional is you could deal with that negative if you wanted to. I don't really love negative values, so instead of sine negative 105, what could I write?
Negative sign.
Yeah, because sine is an odd function, so we can bring that negative out front. So now I can just find the sine of 105 from my identities, and then I can just put a negative in front of it or change the sign at the end. Okay, so if I want to find sine 105, what group of identities would be helpful? Do you think? Sum and difference. Can we find two angles that add or subtract to 105? On our unit circle. Remember, they have to be unit circle values. What could we use? Perfect. And those are both in quadrant 1, which makes it nice because I don't have to worry about negative signs. All right, so this is the sine u plus v identity. So this one is sine cosine plus cosine sine. And now you need to find those four things from your unit circle. What is the sine of 60?
Do we have a formula sheet on the test?
You will. You'll have the whole formula sheet and a blank unit circle. Yep, same one for both parts of the test. Sine 60. What is it? Rad 3 over 2. Cosine 45. Rad 2 over 2. Cosine 60. A half, and sine 45. Rad 2 over 2. Okay, so I have rad 6 over 4 plus rad 2 over 4. So I get rad 6 plus rad 2 over 4. Okay, that's the sine of 105. So the opposite of the sine of 105 is you can just put a negative in front of that whole fraction. Another option is you could distribute the negative through like the numerator and make it negative rad 6 minus rad 2, but I would accept this answer. That's fine. Okay. You could leave it with the negative 105. You could do like, I don't know, negative 60 minus 45 and do it that way, but you're going to have negative angles likely within the identity. So I think this is a little prettier. Okay. Any questions there? Sum and difference? Okay. Moving on. Number 3 is just finding another exact value. Go ahead and pick one. 54. Okay, I might actually delete what I have at the bottom here so I have a little bit of room. Well, let me see if I can do that. Select. I can't. It doesn't want me to do that. Okay. Well, we'll just deal with it. All right. So 54. Okay, I am finding cosine u minus v. And we've got all this other information at the top. So before I actually even deal with my identity and my proof or whatever I need, I'm going to go back to what I'm given. Okay, so we saw some problems like this before. It tells me a tangent of u in this case. And it also says u is in quadrant 3. If it tells me what quadrant it's in, what should I probably do? draw a triangle in quadrant 3. Please draw your triangles correctly. If you do not draw the triangle correctly, it becomes a hot mess very quickly. Okay, remember the right angle should be on the x-axis, and then I'm going to label it. This is U. That angle is near my origin. Tangent is what two sides? Opposite. Adjacent. What's going to be the hypotenuse then? 5, okay, or you could use Pythagorean theorem if it's not a triple. Is there anything else I'm missing in this triangle? Yeah, you need to make sure if you go to the left or you go down, they're negative. Okay, so I'm just going to leave that there. I also know sine of V is 5/13 and V is in quadrant 2. So I'm going to draw that one. Okay, again, right angle on the x-axis. Angle near the origin. Sine is what two sides? Opposite. Hypotenuse. This is another triple. What's the missing side? 12. And then are there any negatives that I need to include here? 12 is negative. Okay, so now let's go to our problem. We are trying to find the cosine of u minus v. And we have an identity for that. It is cosine u, cosine v, plus sine u, sine v. And these four things now, you should be able to find fractions from the triangles, ratios that you can replace with the sine and the cosine. So from triangle u, what is the cosine of u? Negative 4 over 5. From triangle v, what is the cosine of v?
Negative 12.
Yep. Sine of u.
Negative 3 over 5.
Yep, and sine of v. That was actually a given one, I think, right? 5/13. Okay, so I get 48 over 65 minus 15 over 65. My final answer is 33 over 65. This one, because we don't know what u and v are, we can't really check the answer in our calculator, but you can definitely check your triangles, check your ratios, that sort of thing. Biggest mistakes on these problems are either forgetting to draw the triangles, drawing the triangles wrong, or forgetting negatives, which are the biggest issues people have. Okay. Questions on number 3. All right. Number 4. This is a double angle question. I will only ask you to do one double angle. Okay, so pick a number first. 10, okay, and then pick either A, B, or C. Do you guys want to do a double angle for sine, cosine, or tangent? Tangent, sure. Okay, so we have secant theta is negative rad 3, and you can make it negative rad 3 over 1 if you want. See a fraction. And we know sine of theta is greater than 0. We need to find tangent to theta. If, that's not a 0, that's a 1. There we go. If they're telling me that something's like greater than 0 or less than 0, what information is that giving me? Where it's located, quadrants. Okay, so sine is positive and secant is negative. So let's think back to our little all students take calculus. If sine is positive, but secant, which is the reciprocal of cosine, is negative, what quadrant am I in? Got to be in quadrant 2. That's where sine is positive in either 1 or 2, but something else is negative, so it's got to be in quadrant 2. Okay, if I'm in quadrant 2, what should I probably do? Draw a triangle. When in doubt, draw a triangle. Okay, and this is theta. Okay, again, secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So what I see here is hypotenuse and adjacent. Now, the negative in my little fraction there is with the rad 3. Does that mean it has to go with the rad 3 in that fraction? Remember, the negative can go on the top or the bottom. Look at the picture. What does it make sense to be at, with the rad 3 or the 1? The 1 is negative. Yeah, okay. Hypotenuse should always be positive. And then this is not a triple, so we need to use our Pythagorean theorem to get that missing side. Okay, so I'm just going to call it y. Y squared plus negative 1 squared equals rad 3 squared. Please do not put this in your calculator. Bad things will happen, I promise you. Okay, what is negative 1 squared? It is 1. What is rad 3 squared? It is 3. Subtract 1, I get 2. So y equals plus or minus rad 2. Again, in the picture, I can see that it's going to be a positive rad 2. Okay, once you have your triangle, you are ready to use your identity. Remember, tangent to theta doesn't mean we're finding the tangent of theta and doubling it. That's different. That's 2 tangent theta. If we see 2 next to an angle, you are using your identity. Okay, so we are doing, the identity is 2 tangent theta over 1 minus tangent squared. So we are going to use the tangent, but I'm plugging it into this formula. From the triangle, if I do tangent theta, that's opposite over adjacent, which would be rad 2 over negative 1, or just negative rad 2. You can see from the triangle. Okay, and I'm going to plug it in. 2 times negative rad 2 all over 1 minus negative rad 2 squared. So on top, I have negative 2 rad 2. On the bottom, 1 minus, what is negative rad 2 times itself? Negative rad 2 times negative rad 2. It's just positive 2. So I have that on top still, negative 1 on the bottom, and then negative 2 over negative 1. The negatives cancel, and I am just left with 2 rad 2 as my final answer. Tangent is the hardest out of the 3 identities because you have a fraction. If you look at all of your double angle identities, the sine and the cosine ones are significantly easier because we don't have denominators that we have to worry about, like rationalizing and reducing and that sort of thing. Joe?
Is it going to be in this order?
The test will be in the same order.
So it'll be double angle like this question.
Number 4 will be a double angle question. Yes. And number 2 and 3 will be sum and difference problems. Yes.
So like, say we did like sine 2 theta, we just use like the double angle identity for that?
Yes. And another way to get tangent, by the way, is you could do sine 2 theta divided by cosine 2 theta if you really don't want to mess with this formula. It does get a little gross. Okay. Any questions on that one?
How did you get the negative 2 in the numerator?
I multiplied 2 times negative square root 2. Is that what you're asking? Yeah.
Oh, because the whole thing is negative.
The whole, yeah. If I multiply a positive times a negative, it's negative. Yep. Okay, good on that one? All right. Got 3 more. That's it. Number 5, find an exact value. Pick a number. What do we like? 48? Sure. All right, so I have cosine of negative 3 pi over 8. Again, I would probably recommend making that a degree because it's going to be easier to figure out what we're dealing with, I guess. Okay, so if I take, well, actually, before I even do that, what can I do with that negative? How about I just get rid of it because cosine's an even function. Okay, so 3 pi over 8. If I multiply that by 180 over pi, what am I going to get? 18, I think we should have a decimal for this one. 67.5. Okay, and the 0.5 should be a little bit of a giveaway about what group of identities we're going to use. What do you think? What group of identities are we going to use? Nope. That's half angle. 0.5 is half of something, right? Okay, so that's our next job, is to figure out 67.5 is half of what on our unit circle if we're doing this right. You can always just double it if you're not sure. 135. And that 135 is the theta that you're going to use in the half angle identity. Now these identities are the ones that have plus or minus. We'll deal with that whenever, okay? And then it's square root of cosine's the one with the plus, right? 1 plus cosine of our angle, 135, all over 2. I'm just going to go ahead and deal with that plus or minus right now. I'm evaluating cosine of 67.5. If I'm a cosine of 67.5, I'm in quadrant 1, right? So what am I going to be? It's positive, okay? It's just the original thing you're evaluating. Figure out what quadrant it's in. If it's quadrant 1, it's positive. If it's quadrant 2, you just got to consider what function. Okay, so it's positive. So you can either put a plus there or you can just drop it all together. What is the cosine of 135 from your unit circle? Negative rad 2 over 2. And then it's still over 2. So then how we simplify this, the first thing that we deal with is that little 2 in the denominator that we don't want. So we're going to multiply by 2 over 2. So I have square root. When I distribute the 2 through the numerator, a little pen out here, there and there, I'm going to have 2 minus, and then my 2's will cancel, rad 2. If I multiply it in the bottom, I get 4. And then when we have a square root of a fraction, it's just square root the top, square root the bottom. The square root of the top, we can't do anything with that. Square root of the bottom is just 2, and then that's your final answer. This is one that you can absolutely check in your calculator. Type your problem in. You can put it in radian mode, type the exact original problem in, type the answer in, make sure they match. Okay, questions on that one?
So how did you get rad 2 in the numerator?
So I multiplied this 2 into the numerator here and here. So if I multiply 2 times 1, I just get 2. This 2 is on top here. So 2 over 2 is canceling.
Oh.
And I'm left with rad 2. You could also get a common denominator. Like you could make this 1 a 2 over 2. Just don't forget the bottom. It would have to be a 4 over 2. And then if all the denominators cancel, this is what you'd be left with.
So the top would just stay the same. Like that second part of the numerator, like rad 2 would just stay the same.
Right.
Okay.
Yeah.
I think I remember it.
Yeah, we did it both ways.
Yeah.
Yep.
How do we know that square root 4 is positive 2 and not negative?
Because we already addressed that when we take the square root, the square root will be positive at the end because my cosine is in quadrant 1.
You use like the first value, like 67.5 for,
Yeah, I mean, you could use this one too. That was the easiest one to use because these are all equal. It doesn't matter which one I look at. You could use this one. I mean, this is in quadrant 4 if I look at it, but cosines in quadrant 4 are also positive, so it's going to give you the same answer no matter which of those that you look at. If you've done it right, it should. Okay. Any other questions on number 5? Okay, next. Let's look at these guys. Pick a number. 13. Great. Okay, so I have cosine 140, cosine 20. Okay, so we're kind of, if you guys are noticing, like working our way down through our identities, right? We did sum and difference, we did double angle, we did half angle. The next groups are the sum and difference, or sum to product and product to sum one. Here I have a product, okay? So we can make that into a sum, and hopefully if we're doing it right, that'll help us evaluate at least a little bit, okay? It can get really messy if you try to evaluate each of these things, because if I try to find cosine 140 in itself, that is a very large problem. And then cosine 20, same thing, and then I'd have to multiply those together. So if you see two functions multiplied, you're using sum to product, or in this case, product to sum, okay? All right, so these are the ones that have the 1/2 in them. I need to remember these guys with my little pluses and minuses. All right, so cosine times cosine is our first one. All right, so these are both cosine. And it's the first angle minus the second angle, x minus y, and then plus cosine again. We add our angles. Just remember, keep them in the same order they are given to you. Okay. All right. So the first one will be cosine 120. The second one will be cosine 160. cosine 120, that's on our unit circle. What is the cosine of 120? Close. Negative half. Yep. Plus cosine of 160, I can't find an exact value for, so we're just going to leave it. Okay. Then I'm going to distribute my 1/2 through, so it gives me a negative 1/4 plus cosine 160 over 2. And the only thing I can do now is add those together by getting a common denominator. What's my common denominator? 4. Okay, so I can think of this as a 4 over, oh no, as a 2 over 4. I'll write that wrong. There we go. So my final answer is my numerator, -1 plus 2 cosine 160. And again, that's as far as we can go because we don't know what the cosine of 160 is, over 4. If it was another value that was on our unit circle, we could simplify a little bit further, but in this one, that's all we can do. Okay. Okay, good. On that one, questions? Nada? No? Okay. And then I think this is the last one. Yep. Okay. So this is the last one's gonna be on tomorrow's test. Pick one. Which one? 15? Okay. Okay, so these problems, this last problem, it's kind of like a grab bag. It could be any of our identities. The goal here, if you guys remember doing this on the quizzes, we had 1 or 2 of these, I think, is not to actually evaluate what cosine of 105 is, because that, again, in itself is a big problem, right? We have to add and subtract, and we have to simplify with an identity. Instead, your job is to recognize which identity on your sheet has been used. So ignore the angle. We have a 2 cosine squared minus 1 here. What is that identity that's been used?
Cosine. Yeah.
It is cosine 2x, or 2 theta, whatever angle you want to use for that. And what is the x that they plugged in here? 105. 2 times 105 is 210, and then if you're doing it right, this should be something on my unit circle. What is the cosine of 210?
-√3.
That is correct. If you do any more work than that on the last problem tomorrow, I will be upset with you. Somebody's going to try to do it. Every year there's somebody that writes and writes and writes for like a half hour on this problem, and it is not necessary. Okay? That's it for tomorrow. All right, so there's a bunch of extra practice problems in Polaris. You guys have circuit training that's a really good practice. And then tomorrow we'll do the first part of the test. Friday we'll just practice proofs as much as you want. And then we'll take that part on Monday. And then we are summarized with this chapter, all set. We're good. We're done. All right, I'll do cell phone lotto, last 15 minutes of yours. Let's see here. 22. My winner.
So easy that, you know, and then hardest not that 4